So here's the derivative of the next inverse trigonometric function, inverse cotangent. So let's say y equals cotangent inverse of x. And what is the derivative of y? Once again, let's look at values of x and y, ranges of x and y. X can be any number. And y can be between, for cotangent inverse, y can be between, cotangent is cosine over sine. Я сначала сейчас начну. Да. Сейчас, то есть что-то. Почему надо пара? Плюс x squared. Собственно, наверное, это и не нужно. Cotangent inverse. Cotangent inverse, как cotangent inverse получается. Cotangent так, cotangent так, надо пара. Cotangent, что я сказал? Именно для cotangent это не очень важно. Ладно. So now I will explain the derivative of the next inverse trigonometric function, inverse cotangent. So let's say f of x equals inverse cotangent of x, and I want to find the derivative. In other notations, y equals inverse cotangent of x, and we want to find the derivative of y. In this context, x can be any number. And now how do we find this derivative? So this function y equals cotangent of x can be defined by the equation x equals cotangent of y. So y equals inverse cotangent of x means that x equals cotangent of y. And we treat the given function f of x, treat y equals cotangent inverse of x as a function given implicitly by this equation, x equals cotangent y. And now, when we calculate derivatives of functions given implicitly, we use the trick left-hand side derivative equals right-hand side derivative applied to this equation. Now, in this equation, left-hand side is x, so the derivative of that is just 1. So left-hand side is x, therefore derivative of left-hand side is just 1. Right-hand side is cotangent y. And so, the derivative of right-hand side should be calculated as derivative of this expression normal way, but then always multiply times y prime. So derivative of cotangent is negative cosecant squared, so it will be negative cosecant squared of y, but then we need to multiply times the derivative of y times y prime. So this is the right-hand side derivative. And now, since left-hand side derivative equals right-hand side derivative, so we get the equation y1 equals all of this. So, we get 1 equals negative cosecant squared of y times y prime. And from here it's very easy to isolate y prime and find the derivative, so y prime equals 1 divided by this, so it's a negative 1 over cosecant squared of y. Now, this is a good solution for implicit derivative of implicit function. However, when we calculate derivative of inverse inverse cotangent. So what we need is, we need to express this derivative as a function of x. So need to express it as a function of x. And in this context, x equals cotangent of y. So x is cotangent of y. So we need to express this formula as a function or formula involving cotangent of y. But this one has cosecant squared of y. So we need to express cosecant squared or cosecant as a formula involving cotangent. So need to express cosecant of y as a formula with cotangent of y, because then we will be able to replace it with x. Now, how do we do that? We start with the main trigonometric identity, sine squared plus cosine squared equals 1. In this case, it's sine squared of y plus cosine squared of y equals 1. Sine squared of y plus cosine squared of y equals 1. And now we need to have cosine, cosecant, and cotangent. And for that, we'll divide all of this equation over secant squared, over sine squared, like sine squared of y, sine squared of y, and here sine squared of y. Why is this convenient? Because sine squared over sine squared is just 1. Cosine over sine is cotangent, but since they're both squared, so it will be cotangent squared of y equals, and this 1 over secant squared, 1 over secant is, 1 over sine squared. 1 over sine is just cosecant, and 1 over sine squared is therefore cosecant squared of y. And that's precisely what we need. Cosecant squared of y is expressed as 1 plus cotangent squared. So what we need now is to plug in this into this equation, and so we get y prime, the derivative happens to equal negative 1 over cosecant squared of y, but since cosecant squared of y equals 1 plus cotangent squared of y, so it's a negative 1 over 1 plus cotangent squared, cotangent squared of y. But since x equals cotangent of y, so this is 1 plus x squared, so it's a negative 1 over 1 plus x squared. So here's what we got. If the given function is inverse cotangent, then the derivative of inverse cotangent happens to be negative 1 over 1 plus x squared. This is the derivative of inverse cotangent function.